Hello everyone, this is Rohit Prajapati. I am first of all thanking EMERTXE, which is an information technology private limited company, for giving me wonderful opportunity for participate in this free IoT internship. I am so grateful to you and now also Jayalakshmi and Daniel ma'am. She has explained everything clearly in this internship, and now also who taught me C and C++. She has also done her best. Thanking you, EMERTXE company, for organizing this event. Thank you so much. I am a second year graduate student studying in Ram Govind Institute of Technology, Kodarma, Jharkhand. So now I am going to give presentation on IoT based home automation solution and what we have learned during the internship. Let's start. This presentation is on the base of home automation solution. Now see what we have learned in this internship. Course content introduction. First of all, we will learn introduction to IoT, introduction to embedded system, C++ language, about project, architecture and project requirement, simulation and conclusion. कौन था मैं? And next slide is embedded system. Let's see what is embedded system. An embedded system is a specialized computer system that is designed to perform a specific function within a large system. An embedded system are designed to be reliable, efficient, and site effective. Embedded system often operators in real-time environment where fast response time and required for safety or other critical reason. Embedded systems play a crucial role in modern technology and have become increasing important of the number of connected devices. Congratulations to grow. And next is about embedded system, block diagram of embedded system. We have better understood than the block diagram. The main part of embedded system is CPU. Under the CPU, all are connected to monitor like software, memory, data conversion, aux power coding, etc. Diagnosis port, user interface, add conversation, ASIC, and actuators, conversion to actuator, and external environment and sensor. This sensor the conversation with CPU. Next is type of embedded system. First, mobile embedded system. Mobile embedded system are embedded in mobile phone, camera, etc. And second is stand-alone embedded system. Stand-alone embedded system work by receiving the input without using any host system for desired output. And third one is real-time embedded system. Real-time embedded systems are designed to perform a specific task within a time frame. And four is network embedded system. Network embedded systems are usually general purpose processor. And next is C++. Topic cover in language, basic syntax and data type, operators and arrays, function and pointers, processor, storage classes, string. And topic cover in C++ language, basic syntax, classes and objects, and construction and destruction. And about the project, this is a small block diagram about the project. What we need, first of all, an smartphone mobile app. To the mobile app is wireless connected to the mobile tower, Wi-Fi hotspot, and internet. Internet is connected to the home, and we have control through the mobile all the home applications like lamp, fan, TV, refrigerator, air cooler, washing machine, and more. Project 1, Garden Light Control. Description: read the LDR sensor value based on the reading from LDR. Vary the brightness of the LED switch which is responsible controlling garden light based on the availability of sunlight. In garden system, we install LDR circuit simple, which is value based on light sensitive. In dim light, light is automatically on, and daytime light is automatically off. In garden light control system, it is also controlled by the mobile app to the blinking. Project requirement: garden control system, an Arduino LDR circuit, and light. Requirement for garden light control: input LDR process, read the LDR values sensor value based on the reading from LDR, vary the brightness of the LED which is visible controlling garden light based on the availability of sunlight, output garden light. And second project is on the temperature controlling. Temperature controlling system consists of a heating resistor, an LM35 temperature sensor, and a cooler, which resemble an temperature controlling system at home. Read the temperature from the temperature sensor LM35 and display it in the LCD. Control the temperature of the system by turning on off the heater and cooler through the Blynk IoT mobile app. Blynk IoT app and is connected to the Arduino Uno, and Uno is connected to the CLCD and temperature system. Project requirement for the temperature controlling system: input temperature sensor, Process read temperature from temperature sensor LM35. Output display temperature on gauge, display temperature on CLCD. And the third project is cooler control system. Input button with color on Blynk IoT app. Process detect change in the logic level. Output if the button is logic high, turn on the cooler. If the button is at logic low, turn off the cooler. Requirement number 4, heater control system. Input button with heater button on Blynk IoT app. Process detect the change in the logic level. Output if the button is at logic high, turn on the heater. If the button is a logic low, turn off the heater. And the next requirement is for threshold control. Input temperature sensor. Process read and compare the temperature with H35 degree. Output if the temperature is more than 35, turn off the heater and send notification to Blynk IoT app and display the same on the CLCD. Next is IoT based humidity and temperature monitoring system. Project architecture. The 4 stages of IoT architecture solution. Primary analog data source device, machine, people, tools, car environment, building, etc. The first stage of IoT solution architecture is sensor like humidity sensor, temperature sensor, noise sensor, and light sensor like LDR. And the second one is internet gateway data acquisition system. It means we need to data connection through the Wi-Fi or internet, cell tower, etc. And third is edge IoT pre-processing. It means we need a device through which connected all the things. And last is data center cloud data storage system like a hard disk or cloud. And next is layer of architecture, precipitation layer, camera, robot, sensor and meter. And for transport layer, routing, Wi-Fi, Bluetooth transmission. And processing layer, web series, web service, data center and cloud. And application layer is smart health, home, smart city, smart grid. And the next slide is simulation about temperature control system. And this is the control panel about the temperature system. If the temperature is high and then the fan is on and the temperature is cooling down, then the fan is turn off. Simulation of temperature control system. This is a block diagram of control system, temperature control system. In block diagram, a Arduino Uno device and LCD and some electronic component and light sensor and temperature sensor. These all are interconnected to last conclusion. Using Blynk IoT application and visualizable simulator, simulated home automation where LED, temperature system, cereal tank, reasonable light, heater, cooler, and water tank in real time. CLCD act like a dashboard used for displaying the event which from Blynk IoT app, like button which are used to control heater, cooler, and inlet valve, outlet valve. Gauge which to display the temperature and volume of the water. Thank you, EMERTXE, for giving the best opportunity. Thank you.